So this particular question was taken from, I think it was exercise 3, exercise 2 it might have been, but it's part B of that. And the reason we're going through it is because of those exponents that are fractions, which can be quite intimidating. So let's go through where the marks are allocated. The first thing we're looking for is, do you recognize the fact that 9 is the same as 3 to the power of 2? And we call that mark prime factors because we're seeing that you can change 9 into 3 to the power of 2. Another example of a prime factors question would be something the other day we had a problem with 75 and we changed it to 3 times 5 to the power of 2. Remember, you can use your calculator for that. The next mark is for when we raise the exponents. And raising the exponents is where we take the exponent on the outside of the bracket and we multiply by all of the exponents on the inside of the bracket. So I did some calculations over here. It was 3 to the power of 2. I multiplied by a half so that I got 3 to the power of 1. And I did those kinds of calculations with both the numerators and the denominators. The thing you've got to be careful with is that this 3 does actually have a power of 1 up there. It's just not written. So you just have to remember that it's going to be there. The next step I did was I simplified the numerator. In other words, I added the exponents. The bases are the same. So they were multiplied by each other. I added them and I got x to the power of 1. So I had 3x over 9x. I was then able to cancel, leaving me with 1 over 3 as my final mark. This method mark over here is just to indicate that there was a correct method done at some point over here that involved cancelling or getting rid of the exponents. There are many different ways you can get there. So this particular question is testing the exact same thing as the previous question. We're looking for if you can change things to products of their prime factors. So 27 is the same as 3 cubed, and 8 is the same as 2 cubed. The next thing the previous question tested was, do you know that an exponent raised to an exponent are multiplied by each other? So x was on the inside of the brackets. 3 is the exponent on the outside of the brackets. X times by 3 gives us 3x. And that's what I've done both in the numerator and the denominator. I then simplified the fraction as much as possible, and I was able to see that things are just going to cancel out nicely. We really like nice answers, and that doesn't mean that you're always going to have nice answers, but we prefer them because they're pretty. So this question over here is looking to see if you know how to simplify the numerator and the denominator, and then after that, whether you know that that exponent that we're raising to the power of, it applies to all of the exponents on the inside. So if we go through what I've done 3 times by 2 gave me 6. Then a to the power of 3 times by a to the power of 5. The bases are the same, which means I can add the exponents, so it becomes a to the power of 8. The denominator is boring, we can do nothing with it. However, in the next step, we can do some cancelling. 6 divided by 12 gives us 1 over 2. Then I've got a to the power of 8 and a to the power of 10, which leaves me with a to the power of 2, which would then be in the denominator. And lastly, I've got that b hanging around. The next thing you will be assessed on is whether you know that that exponent on the outside multiplies all of the exponents on the inside, but you must keep in mind that the numbers and letters or variables without exponents have an exponent of 1, and you put those in over there. And that's it. That's how you would get your answer. When we add and subtract fractions, that's the only time we need to find the lowest common denominator. Not when we're multiplying and dividing, only when we're adding and subtracting. In this case, the lowest common denominator was 18x to the power of 3 times by y. And I've gone through all of the denominators over there and figured out what each one needs to be multiplied by in order to get to 18x to the power of 3y. I've then taken that amount that I'm multiplying the denominator by and multiplied the numerator by it. This line underneath is just a fancy way of writing the calculations that are above. So rather than writing 7 with 3x squared y, I've done 3x squared y times by 7. And then over here, I did the 2x squared times by 2, and lastly, 6y times by 1. You don't have to write it like that, it just looks pretty. And then in the next step, I multiplied out those brackets. I can't do anything more because I don't have any common terms, like terms. I can't take out a common factor. We are just stuck where we are. And that's the end of the question. The main marks over here come from finding that common denominator and then working through with that. So common denominator is everything. Okay, so whenever we are dividing or multiplying fractions, we can look at cancelling and stuff like that. However, we can't do that when we've got more than one term. In other words, in the numerator over here, we've got x minus 2. Those are two different terms. They are split up by that term, or that plus or minus over there. When that happens, we have to factorize everything. X minus 2 can't be factorized any further. I put some brackets around it so that it feels like I can just cancel it just now. I've got a trinomial in the denominator. In the numerator of the other fraction, I've got difference of 2 squares. And in the denominator, I'm taking out a common factor. The other thing that's very possibly going to pitch up in any kind of question is that I am multiplying or dividing, which means I don't divide by fractions, I change it to multiply, and I invert the fraction. I can then do some fancy cancelling. Anything on the top can cancel with anything on the bottom, as long as they're being multiplied together, and that's what I did, and there's my final answer. This could very easily be worth 5 marks, because you're factorizing, 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 changing to the reciprocal, so that's 4 marks, and the last mark is for writing your answer.